So now let's look at another question here. Okay, so we have y squared minus z squared equal to 9. Okay, so we have two variables here. Okay, so meaning that we have one variable missing. Okay, so for this case, how we want to solve it? Okay, we need to have one trace only. Okay, because we only have one variable missing. Okay, alright. Okay, so now the first thing is what will be the equation is this? Okay, y squared minus z squared equal to 9. Okay, we have looked at the previous example. Okay, for the cylindrical surface. Okay, for cylindrical surface we have plus, right? We have plus, but this time we have minus. Y squared minus z squared equal to 9. Okay, so if you look at the previous video, you should know what type of equation is this. Okay, so basically this is a hyperbola. Okay, so this equation is hyperbola, a type of hyperbola. Okay, because we have the negative here. Okay, so you need to recall back your standard equation. Okay, the characteristic of the equation. Okay, so how you want to convert this into the hyperbola? Okay, so we have y, so meaning that is involve y and z axis. Okay, so for hyperbola, the right hand side must be equal to 1 here. Okay, so what we need to do, how we want to transform this equation into 1? Okay, so meaning that we need to divide both sides with 9. Okay, so we'll have okay, so we will have y squared minus z squared over 9 equal to 9 over 9. Okay, so we'll have y squared over 9 minus z squared over 9 equal to 1. Okay, so we can have the hyperbola already. Okay, so now this is y and z axis. Okay, so we want to have a one trace, y and z. Okay, so let's say this is the trace. Okay, so now for this case, we know that the negative part here is at the z. Okay, so meaning that our hyperbola right now is vertical or horizontal. Okay, so it's y minus the z. Okay, so meaning that in this case it is horizontal. Okay, it is on the y axis. Okay, so basically it will be, okay, so you need to look at back the standard equation for the hyperbola, yeah. Okay, so it will be here like this. Okay, alright, so from here basically we need to rearrange first y squared over 3 squared minus z squared over 3 squared, which is equal to 1. Okay, so the 3 is basically is the vertex here. Okay, so you will have 3 and minus 3 here. Okay, because the 3 given here is referred to a. What is a? A is this one. This is the value of a. Okay, between the vertex and the, in this case, the origin, the center, the HK. Okay, this is HK, but HK here is 0. What is HK? So the y minus h and the z minus k, alright, over the a squared equal to 1. Okay, so this is the standard equation. Okay, you need to get back. Okay, you need to just check again. Alright, okay, since this one here is 0, okay, 0. Okay, here a 0 0 lah in this case. Alright, okay, so now what's next? Okay, so we only have one trace here. Okay, so now we need to okay, so if we have 3 variables, meaning that we need to combine, right? We need to have 3 traces and then we combine, but since we only have 2 variables here and 1 variable is missing, so we need to have 1 trace only. And then after that, what we need to do is we need to do the projection. Alright, so this is y, this is z, this is x. Okay, so we have our hyperbola here is at the front wall. Okay, so basically it would be here. Okay, so it located here and it's located here. Okay, alright, so you have 3 and minus 3 here. Okay, so now what you need to do is you need to project. Okay, so let's say you have another, you do a projection. Okay, let's say, oops, let's use different color. Okay, let's say this is your another axis. Okay, so you project. Okay, so on this axis, okay, so you will have your projection. Okay, alright, so it's on 3. And here. Okay, alright, so it will be project here lah. Okay, so let's make it a more curvy. Let's make it a more curvy. Okay, so basically it will be like this. Okay, so you just project, make it more curvy so that I can draw. You can look at that one. Okay, alright. Okay, so basically this is your graph. Okay, this one. Alright, and also this one. Alright, this one. Alright, okay, so basically what type of equation is this? Okay, it is a hyperbolic cylinder. Alright, hyperbolic cylinder. Okay, alright. So now let's look at the next example. Okay, how about this one? Y equal to y squared. Okay, so we don't know what type of equation first. Okay, but this one already displayed parabolic cylinder. Okay, so now for y equal to x squared. Okay, so we have one variable missing, which is z, right? Okay, so for this case we need to do one trace only. Okay, for x equal to y squared. Okay, so it's easy. So you have the x, you have the y, so y squared. Okay, alright, so you will have this one lah. Okay, how to sketch it? Okay, okay, but if you have y equal to x squared, is normal lah. Okay, so we have x and y, and we have the like this. Okay, but for x equal to y squared, okay, so it will be this one here. Okay, so alright. Okay, so now what we need to do is we need to do the projection. Okay, so we need to do projection. Okay, so we have x, we have y, we have z. Okay, so it is on the floor. Okay, so it is x and y plane. Okay, so it would be, okay, how do you to scratch that? Okay, so it would be like this, right? Okay, so what we need to do is we just need to do the projection. Okay, let's say, okay, so you have another curve here. Alright, so what you need to do is do the projection line. Okay, you will have a parabolic cylinder here. Okay, alright.